Okay, we're going to look at our laws of exponents. So going over what happens when we do different things that involve our exponents. So starting out, law number one is when I have something multiplied, so a variable with an exponent times that same variable with an exponent, I add the exponents together. Law 2 is similar, that if I have the variable with an exponent divided by that same variable with an exponent, I would subtract them. So what we're looking at here is, if you remember your order of operations, so parentheses and exponents go first, then multiply, divide, then add and subtract. When I'm working with exponents, so when I'm looking at a to the m times a to the n, I'm multiplying. So when I zoom in to just look at the exponents, what happens is I move down a level. Instead of multiplying, I'm going to add together. For this one, instead of dividing, I'm going to subtract. So when I zoom into the exponents, like just looking at what happens with those exponents, I move down a level for PEMDAS. Okay? Law 3 and 4 are both similar. When I have an exponent that gets distributed out, it's the same thing as if I was doing 2 times a plus b. That 2 would distribute out to the a and the b. Same thing here, that exponent distributes out to both. And that goes the same for law 4. The only thing is that b can't be equal to 0 because I can't have a 0 in the denominator. For law 5, this is when I have a variable with an exponent, then to a power again. What I'm going to do is multiply those together. So what's happening is I'm up here as an exponent to another power. When I zoom in on just the exponents, I go down a level and I'm multiplying. So a to the m power, all of that to the n power, I go down from exponents and I multiply those together. And then law 6, anything to the 0 power is just going to be 1. So let's look at a few examples. I've got 3x squared y, all that to the second power. So I'm going to take and square everything. That means 3 is going to be squared. X squared will be squared. And y is going to be squared. So I've got a little more simplifying I can do there. I know that 3 squared would be 9. And x squared squared, when I zoom into those exponents, those are going to multiply together. So I'm doing something to a power, I move down a level and multiply. So that'd be 2 times 2, x to the 4th, and then y squared stays as y squared. That is my answer. Okay, next I've got one with a number I can actually work with, but let's look at that power rule. I've got negative 2 to the second power, then up to the third power. So what I could go ahead and do is multiply those two together and get this as negative 2 to the sixth power. Now since this is an even number, it's like I'm doing negative 2 multiplied together 6 times. And when I do that, every time I do negative 2 times itself, I'll get a positive number. So negative 2 and a negative 2 gives me a 4. And I can keep that going. I end up with 3 4s. I multiply those together, it's 16. 16 times 4 gives me a 64. So really what happens is, anytime you've got a negative number, if the exponent is even, it's going to turn to a positive. If the exponent is odd, so if this was negative 2 to the 5th, I'd get a negative 32. Kind of like one of these 2's is dropping off. So I do 4 times 4 times negative 2. So it keeps it as a negative. But since this one's even, it has to be a positive. Hey, when I've got a fraction here, first thing I'll do is work with my coefficients. I've got 12, and I can divide that by a -4 to get a -3. And then when I zoom in on the exponents, I'm dividing these two variables, so those exponents I'm going to subtract. You've probably seen it, like if I do a to the 7th, there's 7 a's, and a to the 3rd down here. What will happen is I've got some of those that can cancel out, and what's left is 4 up there. So a times a times a times a would be a to the 4th. Really what's happening is I'm doing 7 minus 3 gets me a to the 4th power. Next I'm going to take xy squared and multiply it by this binomial. So when I do that, I'm going to take the claw and multiply xy squared times 3x squared to get me 3, and x squared would be x cubed, so 3x cubed y squared plus 2, and then just an x now, and y to the 4th. Now, to see if I can add these together, what I would need to do is take a look at both of those, and since they are not the same, I cannot add them together. Okay, and looking at the next side, I've got all this 2r cubed s to the 5th, but all that is to the 0 power. So I could take and say, well, that's 2 to the 0 power, r to the 3 times 0, which is 0, and 0. But what happens is everything ends up as 1. So my rule is anything to the 0 power is just going to be 1. So that's what I get there. Okay, on number 7, I get into something a little bit different. So normally I'd look and say, oh, there's a 4 there, and so I can find an actual answer to this. But for this one, I've got a y plus 2 in my exponent. Now I could get 4 to the 6th and get an answer to that. But what happens is I'm actually able to simplify this a little bit more if I combine these exponents rather than doing 4 to the 6th and saying that's multiplied by 4 to this power. So what's going to happen is, as my rule states, since I'm multiplying, those exponents are going to move down a level and add. So I'm doing 4 to the y plus 2 plus 6 power, which simplifies down to just be 4 to the y plus 8. And so then that is as simplified as we can go. And if you get a value for y, then you're able to solve. Otherwise, your answer would just look like that. Okay, number 8, we get into where we have a couple of steps combining this. So first, I have a to the 4th over b, all that to the 2nd. So since I have a power to a power, I'm going from an exponent down to multiplying. So that'd be a to the 8th over b squared. So that exponent will go to both. And then same thing here. I do all that times a to the 6th, b to the 6th. Now we can think of that when these multiply together. If you need to, you can think about that as all being over 1. But what will happen is this a to the 6th, b to the 6th will multiply by that a to the 8th and go over the b squared. So let's do that first. I have a to the 8th times a to the 6th times b to the 6th, all that over b squared. So I've got a few things that will combine. The a to the 8th and a to the 6th will go together to give me a to the 14th. And since I have division going on here, I subtract 6 minus 2 gives me b to the 4th. And all that cancels out there, so I end up with just the numerator, so it's in a whole number format. And the last thing I do is I'm going to use those to solve for x. So when I have it like this, since all these are 3x times 3 to the x power times 3 squared equals 3 to the 8th, I just need to solve for x. So what I can do then is I'm going to zoom into those exponents. And so since these are multiplied, that means these are going to be added. The exponents will add. So it's x plus 2, just for the exponents, equals 8. And so solving for x real quick, I subtract and get x equals 6. Same thing happens for number 10. If I'm zooming into the exponents, I go down a level from division to subtraction. So I do x minus 2 equals 8, where I get x equals 10. And for the last one, same thing. I'll zoom in, and when it's 3 to the x power to the second power, since that's something to the power, I'll multiply them to get 2x, and then that's subtracting 2 from it to equal 8. And when we solve that out, should get x is equal to 5. So we're taking these power rules and really stretching them to their limits and using them for all the different ways that we could think of to solve equations within the exponents, to have some variables inside the exponents with numbers, and to do multi-step equations, all with exponents and variables. So as you're working through that, hopefully this helps. Have a great day.